Biomedical engineering is kind of a jack of all trades.
I would describe it as the perfect unison of both the engineering and the medical fields.
You have your mechanical aspects, your electrical aspects, your software aspects, and even chemistry.
We take a lot of the same courses and are taught content from each of those disciplines, and we apply all of that in a healthcare setting.
Biomedical engineers create applications such as medical devices or systems.
By taking the engineering principles and implementing them to medical purposes, things that are intended to help people.
Instead of working one-on-one with patients, they work more behind the scenes. You're still getting to make that impact daily on people's lives.
Hi, my name is Leo.
Hi, my name is Fatima.
My name is Justin.
Hi, my name is Areeba.
I'm a first-year engineering student.
I am a second-year student.
I'm a third-year student.
And I'm a fourth-year student.
And this is my perspective.
And this is my perspective.
And this is my perspective.
And this is my perspective on biomedical engineering at TMU.
For the structure of the first-year biomedical engineering program, it first involves the foundational courses that apply to any engineer. On top of that, biomedical engineering specifically has a course called BME 100, which I found to be one of the most inspirational courses I've ever taken. It really goes into the nitty and gritty of what biomedical engineering is. It shows real examples of biomedical technologies that are being used, and it's really just mind-blowing to see how much biomedical engineering can impact the medical world. The four main sects, which are tissue engineering, biomechanics, biomaterials, and prosthetics. We got to look at technologies that are in all four and got to really get an idea of how technology is progressing. Before I started the program, I initially thought that biomedical engineering was mostly an engineering-based program and there was very little bio that had to do with it. As I've gone into biomedical engineering, I realized that I need to be well-versed in both engineering and in the medical field in order for us to effectively do our jobs and create these technologies. The advice that I'd give to anyone considering biomedical engineering here at TMU is to first get an idea of what all the engineering disciplines have to offer. If you're still considering biomedical engineering, do your first year, take BME 100, and if BME 100 as a course really resonates with you, then I think that you have a passion and have made the correct choice.
Biomaterials was one of my favorite courses alongside physiology. In both of them, I was able to learn about different biological functions of the human body and how biomedical engineers can actually create medical devices, create artificial biological substitutes to help people. It was really nice to see the actual medical applications of different biomedical engineered things such as implants, pacemakers, prosthetics, to see how they actually affect individuals on a daily basis. In biomaterials, my team and I, we decided to research about the total en-bloc spondylectomy. It's basically a spinal surgery and removing spinal tumors and replacing that part of the 3D printed artificial spine. That's something that really piqued my interest in the tissue engineering aspect of biomedical engineering. Biomedical engineering students aren't restricted to just joining their specialized student groups. They have the opportunity to join a plethora of different student groups. I'm personally a part of the design team TMU Bionics, and within that, our team's goal is to create a bionic arm and go to a competition. As a research sub-team member, it is my responsibility to research different guidelines related to the competition, the bionic arm itself, as well as research current applications of bionic arms on the market, just so that we're creating something that is actually implementable. The benefits of joining a student group or design team is that you get a lot of experience. So yes, you learn a lot of theory in your course. If you do apply that theory in your labs, being a part of a student group or a design team is actually implementing that on your own. So it's really fun designing something that you've seen on paper, but then seeing it in real life is very different.
The TMU co-op program, after your third year, you can get access to a student portal, which will help you get job opportunities to do a co-op. There aren't that many specifically biomedical positions. Because you're taught engineering in electrical, mechanical, and computer, you can apply for those positions. Having a specific biomedical application sort of gets put more into electrical application, but at a healthcare company, or mechanical application at a biotech company. All these you can do biomedical engineering in, it's just not specifically biomedical. I'm at Sanofi, Sanofi Pasteur. They are a pharmaceutical company. Their main focus is on vaccines. My role is engineering technical service. I help with project managers in terms of registrations, renovations, installations, organizing projects, overall helping move towards better sustainability goals. With biomedical engineering, it is very multifaceted. But the thing that pulls it all together is the communication part of it. You're taught a lot about how to communicate from a mechanical perspective to an electrical perspective, and so on. With Sanofi, I definitely have a lot of cross-department communication. The engineering part that I do is most likely to be closest to industrial, but a lot of the communication parts are suited for biomedical engineering. We do have some stuff in second year about electronics, but in third year, you really see it come together. I really liked microprocessors, which is a course that you design circuits, you write code, and then that code makes the circuit do something. It really showed me how this kind of thing works, because it's both really complicated and really simple at the same time. In terms of actually breaking people's perception of how good a biomedical engineer is versus an electrical engineer, that comes down to how well you can connect these other disciplines as well as communicate with these other disciplines. Someone who's amazing at coding, perfect GPA in computer science, how well can they translate that into like chemical bonds? With biomedical engineering, you're more well-rounded, which has its drawbacks, but also has its positives. This also means that you're more future-proofed than other disciplines. As long as you can slowly build up in all these different fields, rather than just completely specialize in one, that means if one of them kind of falls out of favor, you are still able to adapt to the newer stuff.
After finishing my 4th year, I have a completely different perspective of what I want to get into in the industry. After I finished my co-op, I applied to Dr. Kademi's lab as a research assistant, and her research focuses on using artificial intelligence in image processing. What we're trying to do is make artificial intelligence models that will help pathologists diagnose cancer faster in patients. We can get them their medication faster if we diagnose them faster. How am I staying updated with all of these new trends? I use LinkedIn. LinkedIn is where it's at. Biomedical engineering is progressing so fast, so you're not really able to keep up with it just by reading textbooks and other articles and stuff, right? LinkedIn is where researchers and professors continuously update what they're working on. All of the new emerging technology or all of these new projects are coming up on there first, because professors and researchers, they want you to read their papers, they want this publicity. So if you follow the right people, even big companies, they have their articles and everything on there. We talk a lot about getting our devices regulated by the FDA, because basically we're making all of these products, all of these softwares and all of these medical devices, but if we can't get them regulated and approved by the FDA or Health Canada, they're not gonna impact any patient's lives. That whole regulation process, that's a big problem. It takes years. TMU and my co-op placement, besides just the content it taught me in engineering, it really teaches you the critical thinking and problem-solving skills. Artificial intelligence, ChatGPT, all of these large learning models, they're kind of taking over the tasks that people would originally do. But here, you're learning the thinking process that these machines aren't really able to do yet. You're also gaining a lot of your people skills, your project management skills, your teamwork and leadership skills. I feel like all of those skills are going to help me a lot more than the technical knowledge that I've gained.
It's really, really nice that TMU offers a plethora of different courses that I can take as a biomedical engineering student. It broadens my horizon into the different careers I can do, because I'm able to have knowledge on different engineering concepts from different engineering disciplines.
That's the thing about biomedical engineering. There's a lot of different streams. If you don't like a part of it, you don't have to do it. You can choose something else.
I chose biomedical engineering over other engineering programs primarily because of my passion for helping people. I always wanted to be a doctor, but as I grew older, I found that I had good skills in math and physics. Biomedical engineering was the perfect unison of those two.
I really wanted to apply all of my problem solving and critical thinking skills in a healthcare context, because I really wanted to make sure that the things that I was doing was making a difference in patients' lives.
With biomedical engineering, I just saw it as the best way to make an impact that I could get behind. The idea behind penicillin and even the stethoscope, you can make one thing, and if it's successful, it helps potentially millions of people.
Doctors and nurses, they work so hard to treat patients. We can make their lives a little bit easier by introducing all of these new technologies. It's going to make an incredibly huge difference in patients' lives.